Okay, all right. So, in the last session, we discussed about the collection framework, and in the collections, we discuss a lot of things like what is collections, what is collection framework,
Hmm.
and then what is the hierarchy of collections framework.
Mm-hmm.
Then we discussed what is interface, what are the built-in interface, and what are the built-in classes in the
Hmm.
collection framework. Just I'm doing the recap what we have done,
Mm-hmm.
and then we can continue from there so that you have the
Yes.
continuity like what we discussed in the last session.
Hmm.
So we discuss about the hierarchy of the collections framework, then we discuss about the method in the collection interface,
Mm-hmm.
then we discuss what is iterator interface, and then hereafter we discussed about the list interface and the implementation classes.
Mm-hmm.
So there are multiple implementation classes for list interface. In the last session, I discussed about ArrayList and LinkedList
Hmm.
and vector and stack.
Hmm.
So till stack, I had discussed in the last class. From in today's session, I'll be discussing after stack. So we have other
Yes.
interfaces and other implementation classes. So I'll be discussing about those. So the next interface which we have in the collection is queue interface.
Hmm.
So normal queue, you understand right now, in normal queue in the data structure, like it works on the first in first out principle,
Yes.
where the element who comes first will be going out first. So in the normal queue also, if you see, let's say you are in the queue, so if you have come first in the queue, you will be the first to leave from the queue also.
Hmm. Hmm.
So that is the concept of the queue.
Okay.
And this is again that it is inherited from the collection interface,
Mm-hmm.
because queue is the child interface of the collection interface that we have discussed in the hierarchy.
Hmm.
And this is also nothing but array, but the way we manipulate the data, the way we store the data is in the linear fashion.
Hmm.
And with that new way of storing data, here we can perform multiple manipulation operations like adding data, removing data, reading the data from the queue.
Mm-hmm.
So you can see on the right side of the slide, like I have examples written where I have declared a queue using linked list. Either
Mm-hmm.
we know, like there are two ways by which you can implement. Either you can use a array or you can use a linked list.
Oh. Okay.
Anything which you have data structure can be implemented in two way. Either you can implement using array or you can implement using a linked list.
Okay. Okay.
So here linked list I have used to declare a queue, and then you see I am adding the element to the queue. Apple,
Mm-hmm.
mango, these are the uh, examples that I'm adding to the queue. And then
Mm-hmm.
we have a remove method for removing, and then you can print the queue, you
Mm-hmm.
can see the size of the queue, you can see the any element is present in the queue or not. So these are the method that is already available in the queue interface.
Hmm.
So these methods are used in order to perform the multiple operations in the queue.
Okay. Okay.
So queue has the implementation classes. So priority queue is one of the implementation classes of the queue interface.
Okay.
So it implements that queue interface, and here the specification of the priority queue is that the elements which are there in the priority queue, right, it has
Hmm.
a priorities to that all the elements. So when we process that elements in the priority queue, it will be processed by their priorities.
Okay. Okay.
So whose priorities will be the highest will be processed first.
Okay. Okay.
And it does not allow null value to be stored in the queue, so you cannot store a null value. In case of other in collections, right, you could store a null value as well, but priority queue does not allow to store a null value.
Okay. Q in general lets you store null value?
Yes, I think in general you can store a null value.
Okay. Okay, got it.
So here the again process is same, as I have already told you in the last session also. That's the why
Mm-hmm.
I gave lot of time to make you understand the array list and linked list.
Mm-hmm.
The way we create an object of the priority queue is same.
Mm-hmm.
You have to give that priority queue reference and then new keywords to use that priority queue object, and then you can add data to the priority queue and then you can print it. So since it is a queue, right, here
Mm.
we have the few methods like pick and poll, remove.
Mm.
These are very specific method to the queue.
Okay.
Peek is nothing but to read the data. It will read the data from the queue. Remove will remove the data, and poll will also remove the data that we will be seeing in a while.
Okay.
So when you practice, you will come to know like what
Peak.
method is used for which purpose.
Okay. Okay, fine. One doubt I had. So here it's written priority queue is equal to new priority queue. So when I'm creating a queue, like I can create it with queue keyword also, or does it have to be only like array list or linked list, or
No,
how
you
does it
can
work?
create with linked list also and priority queue also. So this is a class, right? Priority queue is a class.
Huh.
So you can create an object of a class, but when you see it here, right? Queue is not a class. Queue is an interface.
Oh, okay, okay, got it.
So you
Huh.
cannot create an object of an interface, right? So to
O-
create an object of an interface, you should have the implementation of that.
Okay,
But priority queue is a class, and you can always create a object of a class.
okay, got it. Yes, understood.
So let me give you the
It's a good
practical implementation.
example.
Yes. So I've tried to cover how much I can cover in the session, but as and when you practiced, many things will come when you do the hands on it.
Hmm.
But I'll try to cover. So here you see this is a Q demo, right? So here I've created the same examples with linked list, and I'm adding it to the queue, and then I'm printing it, and then again I'm removing it from the queue, and again I'm
Hmm.
printing it, and then I'm
Hmm.
printing the size of the queue, and where
That will give you Boolean, whether it
si-
contains or not.
yes, this contents method will tell you with the true and false whether this element which I'm trying to check whether it is there in the queue or not.
Okay, got it.
So let me execute this program, and here you see it is printing. First it is printing the queue. In the queue we have these three elements, right? Apple, mango and grapes. Then I removed grapes, and then again I am printing. So grapes is removed, so I have
Hmm.
two elements in the queue now.
Hmm. Hmm.
So now after removing the grapes, I am printing the size. So it is printing two because there is only two element in the queue, which is apple and mango. And
Hmm.
then
Hmm.
I'm checking that whether that queue contains apple or not. So it is printing true because it is
Hmm.
there. If it does not contain, it will return false.
Okay.
So that is
Okay.
all about queue. And I was talking about the poll method and the remove method, right? So both the
Yes.
methods have the purpose same, but the way it behaves it is different.
Okay.
So here you see both the method will remove the element, but when it has a different behavior at the way it works. So
Okay.
I have two elements in the queue
Hmm.
which I have added A and B, and then I poll one,
Hmm.
and when then in second scenario I remove one.
Okay.
So here you see when we poll right, and then it is printing the element A.
The first element that was entered.
Yes. When we
That follows
remove,
before. Like the first element will be out.
yes,
Hmm.
and when we remove that, right, it is printing B,
Hmm.
because when you remove one, only B is element in the queue.
Hmm. Hmm.
So
Hmm.
B is removed. But after that, when you remove, now queue is empty because both the element in the queue has been removed.
Hmm.
Now you again you call a poll method which is returning a null,
Okay.
right? But when you call this remove method, it will throw you a exception. That is the
Okay.
difference.
Got it.
So both methods are used to remove the element from the queue, but one method returns null when there is no value in the queue, and one method will return you the exception.
Got it. Got it.
So the way it behaves is different. So when you know like there will be a element in the queue, that time you can use remove method, right? So that it will not throw the exception.
Ah. Okay. Okay.
But we are not very sure about the element in the queue. In that scenario, you can go for a poll method, because it does not matter for the poll method whether the element is there in the queue or not. So
Okay.
if there
Okay.
is no element in the queue, it will return you the null value.
Okay.
So here you
Okay. Got
see,
it.
so that is the difference between poll and the remove method. So when there was a element, it removed from the queue, and when there is no element in the queue, it is returning a null. And when there is a, in case of remove, it is, in case of remove, it is throwing a exception.
Hmm.
So that is the difference between poll and the queue, poll and the remove method.
Hmm.
So that is what I have explained you here. This is same, like what is difference between poll and remove. So both are used in the queue, and both behave differently when the queue is empty. So one throws the exception and one throw the null value.
Got it.
So summary which I have told you, right, when to use poll and when to use remove.
Hmm.
So normally we go for poll method when you want to save a null returning operation on the empty
Hmm.
queue,
Hmm.
and we use remove when you are confident that queue is not empty and want an exception if it is. So in that case you can go for a remove method.
Got it. Got it.
So this is queue. Now we'll go to the next interface, that is DQ in the collection interface. So again DQ is again inherited from the collection interface, because collection is the top interface,
Hmm.
and DQ stands for double ended queue. So when we say double ended queue, right, it
Hmm.
supports insertion and deletion operation on both the side of the queue. So you have a linked list, you have a doubly linked list.
Hmm. Hmm.
Similar here we have a queue and double ended queue. So when we say double ended queue, it means that when you, we have a two ends in the queue, right? We call it like rear and front.
Hmm. Hmm.
So
Hmm.
here the both the operations like insertion and deletion can be performed from the
Both
both
sides.
side of the queue.
Okay.
So either you can insert an element from the rear or a front also.
Got it. Got it.
And implementation class for DQ is the array queue.
Array. Array queue.
Yes.
Okay.
So here you see I'm declaring a array queue with the interface reference. One more thing here you need to understand that that I think I have told earlier also. You
Hmm.
can give the reference of the interface to the class which it implements. So here you see I am creating an object of the array queue,
Hmm.
but implementation which I am giving is the DQ
Hmm. Hmm.
reference. So here you can you could have given this also, array DQ num is equal to new array DQ.
Ha.
that is the class, but dq is an interface, and this interface is getting implemented by the array dq. So dq can have the reference of all of its implementation classes.
Got it. Understood.
And here we have a very specific method to the dq, like offer is nothing but insert.
Okay.
And
Offer.
yes, add method is nothing but offer in case of array
DQ.
dq, in case of q as well.
Okay.
So, and here I told you, right, we can perform the operation from the both the sides. So here you see we have a offer last method that will insert the element from last. We have
Okay.
offer first method that will insert your element from the first.
Okay.
Similarly, we have peak first, so it will give you the first element from the queue.
Okay.
Similarly, we have peak last, pole first, and so on.
Okay.
So
Okay.
here we have couple of methods or so many methods that helps you to perform operation from the both the ends.
Got it.
And this is the array dq, that is the implementation of the dq interface.
Mm-hmm.
And we can add or delete the element from both the ends.
Mm.
And array dq is faster than array list and stacks.
Mm-hmm.
And so these are the specific characteristic of this array dq.
Mm-hmm.
So when we have a operation or when we have a requirement that you should be able to add from both the ends, in that case you can go for the array dq, because it gives you the flexibility to add or delete the element from both the ends.
Got it.
So here I was telling you, right, you can have that object creation with the either a interface reference or a class reference. Again, I'm creating object with the interface reference, but you can always create with the class name as well.
Mm.
So let me go to, think I do not have a priority queue. I had explained you, right? Let,
Yes. And it's the same methods, right?
yes, it's the same methods. And see, all the operations will be performed in all of the collections, right? It is just the way we store the data in the collection and when to use what.
Got
So
it.
every collection you go and add the data, you perform the operations,
Mm.
insertion, deletion, and whatever operation it is.
Mm.
But the catch here is which data structure has to be used where, and
Mm.
why do we use it. So
Mm.
unless and until you know the characteristic of the database, you will be not able to choose the correct database, right? So the
Mm.
idea here is you should know each and every collections and the use case of the collections, how it works and when to use what.
Mm. Mm.
So for array dq, let me give you example like this. Here I'll just create a array dq
Okay.
so that I can show you.
Mm-hmm. One question. So all these data structures are going to be dynamic in nature.
Yes,
Okay. And so here you mentioned string. So if I don't mention anything, then I can add any type of value I want.
yes, you should be able to add.
Okay. Okay.
So here you see we have add method also and we have offer method also, and we have this offer first also.
Hmm. Hmm.
Now if you print this, you
It
should,
will be CB.
yes. So you see the output is cb because I'm adding at the first. You could always add at the last also. So we have offer last also.
Hmm. Understood.
So it will add at the end. So you see
Hmm.
D is added at the end. So
Hmm.
here we are able to add with both the ends.
Got it.
So similarly you can perform other operations also, like
Hmm.
remove, update. So those
Hmm.
things you can practice, right, one by one. Take your time, understand how it works, and try to know the characteristic of each collections.
Hmm.
And then once you know, then it will be easy for you to use when you work in a project day to day.
Got it. Got it. Understood.
So this is queue data structure. Now we'll go to set.
Hmm.
So set is again an important data structure and it is used many times, and this has some very specific characteristic which we have not seen yet, so that will be provided by the set.
Hmm.
And again set is inherited from the collection interface, and the main characteristic of the set interface is that it does not allow you to add the duplicates.
Hmm. Unique values.
Yes, so every time you add to the set, that has to be unique. You cannot add the redundant elements in it. That is the characteristic of the set. So when you have a requirement that you don't want duplicate value, set is the best choice for the to use.
Got it. Understood.
And implementation classes of the set are HashSet and linked HashSet.
Hash set and linked hash
Linked
set. Okay.
HashSet. So, and there is another interface called sorted set, and for
Hmm.
the sorted set the implementation classes is the TreeSet.
Okay.
So there are two type of interface in the set category, one is set and one is sorted set. So
Hmm.
for set there are two implementation classes, hash set and link hash set, and for sorted set there is one implementation classes which is tree set.
Got it.
So we will discuss these now in detail, so we will
Hmm.
discuss one by one. So let's move to the hash set. So hash set is the implementation for the set interface,
Hmm.
and internally it uses hash table for storage. The data structure which you use, right, internally hash set is the hash table, and hashing is used to store the element in the hash set. So hashing is one of the concept that is used where we
Hmm.
calculate the hash value of the index at which we are going to store the value, and based on that we store the elements, and it will always contains the unique items. So as I said, we cannot add the duplicate elements in it, so it will be always having that unique items in the set.
Got
So
it.
you can see on the right side of my slide where I have written the example where I'm creating an object of the set and then I'm adding elements to it, and all are unique. So if
Hmm.
you try to add the duplicate
Duplicate.
element, it will not add to the set. So with that we will see in example if I have it. So here you see I'm trying to create a object of a set class, and then I'm
Hmm.
adding element to it, and
Hmm.
I'm using iterator to iterate the element, but you can use the for loop also.
Hmm.
So here you see I'm able to get the data. Now let's try to add a duplicate element and see what happens, whether it adds to the set or not. So I'll just copy this Andrew,
Hmm.
and if you run this program, you see Andrew is not added twice, you are only seeing once in the result.
Okay. But
So
it does not throw an error.
it will not throw you error because syntactically it is correct, right?
Hmm. Okay.
So but the output will be not having that duplicate elements.
Okay.
So here you can see that it is giving you the warning. If you hover on the element, it
Duplicate.
is saying that duplicate set element, but
Okay.
there is no error.
Okay.
So but it will not allow you to add in the result set.
Got it.
So this is the characteristic of the set.
Mm-hmm. Got it.
And then we have next implementation classes, which is linked HashSet.
Mm.
And linked HashSet also has the same capability that it will not allow you to the add the duplicate because
Right.
it is in the category of the set, right? It just
Mm.
that there is a separate implementation classes.
Mm.
And so if there is a separate implementation classes, there has to be some characteristic which is not available in the set class, but that is available in the linked HashSet.
Mm-hmm.
So the last implementation class which we studied was the HashSet. So since linked HashSet is a different class, it will have some extra characteristic which is not part of the HashSet.
Mm-hmm.
So it extends the HashSet class and implement the set interface. So you can say that linked HashSet is the child class of HashSet.
Mm-hmm.
So whatever properties we have in the HashSet will be available in the linked HashSet also, but it will have some extra also.
Mm.
So you see, like HashSet, it also contains unique element. This is same as the HashSet class, but in case of linked HashSet, the extra capability which has this class is it maintains the insertion order of the data.
Mm-hmm.
So where we have requirement like you want to have unique element and you also want to preserve the order of the insertion,
Mm-hmm.
in that case linked HashSet is the best choice.
Okay, got it.
So here you can see that, right, Johnson was added in the end, but in the result set it is showing on the first.
Mm-hmm.
So the insertion order is not maintained,
Mm.
correct?
Mm.
So it is not allowing you to add the duplicate, but insertion order is not maintained in case of hash set.
Mm-hmm.
But let's say I have a requirement, I want to preserve the insertion order of the element. I want like the way it get inserted, it has to be in the same order.
Mm-hmm.
In that case, linked hash set is the best choice because linked hash set give you the insertion order.
Okay, got it.
So here you see I'm creating linked hash set object and then I'm adding data to this, and here again see I have added this duplicate elements, and that we will see that whether it is getting added or not, and we will also check that the insertion order is preserved or
Maintain.
not. Yes. So here you see Peter is not printed twice because it will not allow you to add, because that is the characteristic of the linked hash set, and we'll
Mm.
see that insertion order is maintained or not. So first we added the Peter, then we added Jack, then again we added Peter, then again we added Johnson. So
Mm-hmm.
Peter is not added twice. So I'll just remove this now. And first we have added Peter, so first is Peter, then we added Jack,
Jack,
so Jack, then we
Johnson.
Johnson. So here you can see that the insertion order is maintained.
Yes,
So
got it.
when you have the criteria of maintaining the insertion order with unique elements, you can always go for linked hash set.
Mm-hmm. Understood.
So that is about set. So we covered set interface, and then we covered two of the implementation classes. One is hash set, one is linked hash set, and
Mm-hmm.
we covered like when to use what.
Okay.
So next we have sorted set. So sorted set is again a part of the set interface,
Mm.
and here since it is a set, so that is definitely that it will not allow you to the add the duplicate element.
Mm.
So whenever it comes to the duplicate element, right, you can always go for the set.
Mm-hmm.
So whichever set it is, whether it is a sorted set and set, or whether it is a implementation classes hash set, linked hash set, or tree hash set, they will not allow you to add the duplicate element.
Mm. Got it.
So I was talking about sorted set.
Mm-hmm.
So we'll see that what is the special characteristic of the sorted set here. So the special characteristic of the sorted set here is that when you add that element to the sorted set, right,
Mm-hmm.
it add the data in the natural order collections, like it will add the data by default by in the ascending order.
Okay. Okay.
So that is the characteristic of the sorted set. So when you add, till now we have only seen that it does not allow you to add the duplicate, it maintains the insertion order, but it was not adding data in the ascending order or descending order, whichever,
Hmm.
right? But when we want to have that data to be sorted in a ascending order, by default it does in the ascending order, but you can also do it in the descending order as well. So
Okay.
when we want, like let's say I'm having any requirement where I want the data has to be sorted,
Hmm.
so in that case you can always go for the tree set or sorted set. So tree
Okay.
set
This
is
will automatically sort the
data.
values and yeah, keep it in the set.
Yes.
Okay.
So that is the tree set is the implementation of sorted set. So it is same as the hash set, like it will contain you the unique element, and here the retrieval time of is quite fast because it maintains
Hmm.
the data in a sorted
Hmm.
manner,
Hmm.
and by default it stored the data in the ascending order. So we'll see in the example. So similar, we create the object of the tree set and then we add it to it, and we will see that whether it is getting sorted in the ascending order or not. So
So, tree set and sorted set are two different, and sorted set uses tree set class as its like to create its object.
so sorted set is the interface.
Okay, so
So
that is the parent that has all the methods.
yes, so here you can give sorted set also. So sorted set is the
Okay,
interface and tree set is the class.
okay, okay,
I know
okay.
it is little bit complex, try to
Hmm.
understand as of
Ye-
now, but when you do it right, when you have
Hmm.
that clear understanding, you will get to know like how to use those. And that's why I told you that picture first, where I showed you the hierarchy of
Yes,
the collection
yes, yes.
interface is very very important. When
Hmm.
you remember that picture, or that picture is coming to your mind when I am talking about, and when you are reading about, it will become easy for you to understand, because which are the interface in the collection interface and what are the implementation classes. So sorted set is the interface, and that interface is getting implemented
Implemented
by TreeSet.
tree set. Okay, got
So
it.
that is the way we remember the collection. So always try to have that picture in the mind, that hierarchy
Hmm.
of the collection
Yeah,
interface.
got it.
So
Understood.
now you see I have added data to this tree set, and we see that whether the data is getting added in the ascending order or not. So here you see the data which we are seeing is in the order format. So David is first, then Donald, then Thomas. So this is the string, but to understand the better, I'll just show you the integer value also. So here you see the below example which I have added you. First I added 10, then I added 5, then I added 20. So if you take the ascending order of this value, it has to be 5, 10, or 20.
Hmm.
So
Hmm.
in the result you see it is showing that 5, 10, or 20.
Hmm.
Let's say here I added a value again, I'll add 1. So it has to be the first element in case of ascending order, right? 1, 5, 10, 20. So you see the result is 1, 5, 10, 20. So I am not doing any sorting of the data, but it is automatically doing that sorting for me,
Hmm. Hmm.
because
Got
that
it.
is the characteristic of the tree set.
Hmm.
TreeSet says that it will not allow you to add the duplicate value, and it will sort the data. So let me add a duplicate value and let's see whether it is adding or not. So I will add 10 here,
Hmm.
but
It won't let.
it won't let you to add, because that is the characteristic of the set. Set always have the unique value.
Got it.
So
Understood.
this is, and see, for the uh, ordering of the data, we are not passing anything, right? It by default it is sorting on the ascending order. But if you
Hmm.
want to sort on the descending order also, that can be also done.
Okay.
So we call it something as comparator,
Oh.
that you can pass it and you can tell the tree set that the order has to be in descending order, so it will order the data in descending order. So now see here I am passing this parameter inside the constructor of the tree set,
Hmm.
and this will tell that you have to sort the data in descending order. So now if you run this program, the output will be changed. So now you see it is ordering in the descending order. Earlier it was 1 5 10 20, now it is 20 10 5 1.
Hmm.
So
Okay.
you can customize the result also as per your needs. So if you need it, your data has to be ordered in the ascending order, but
Hmm.
you don't have to pass anything because by default it is doing it. but
Ascending order. Hmm.
but you can do here also ascending order. If you do
AB.
a b, then it will do in the ascending order. So, but we don't have to do because internal implementation of the tree set is in ascending order. So, if you don't pass, also it will do in the ascending order. But if you want to do in a descending order, you have to pass this comparator in the tree set constructor that will tell the tree set to order the data in the descending order. So, whichever is the needs, you can choose as per your requirement.
Okay. Got it.
So, this is tree set. So we covered one part of the collections which I showed you in this
Hmm.
slide.
Yes.
So this is all collection in the Java that I have covered you.
Hmm. Hmm.
So this picture is very very important. You should always remember this picture because
Okay.
this picture summarize the collection interface or collection framework in the Java.
Hmm. Hmm.
So rest if you understand one interface or one implementation classes, remaining it becomes easy to remember because all are same, it's just that characteristic is different.
Got it. Understood.
So you should have that clear image in your mind of this slide.
Understood.
So that is the part 1. Now we will now study about HashMap. So there is a
Okay.
map interface.
Okay.
So we'll see like where it is used and what is the internal working of HashMap and what are the use cases of this HashMap and map. So this is the another, you can say, part B of the collections where this is
Hmm.
also used many times.
Hmm.
So here also which you are seeing in the light yellow color is the interface and the
Okay.
light red is class. So
Class.
we have two interface, map and sorted map.
Okay.
And for map interface, we have two implementation classes. One is HashMap, one is linked HashMap.
Okay.
So, and for sorted map, we have tree map. So sorted map is the interface and tree map is the implementation
Class.
class.
Implementation.
So this is another picture that you need to remember.
Yes. Got
So
this. So this does not fall under collections like some other thing.
no, it does not comes under the collections,
Okay.
but it is used in the Java to have the data
Okay. Why is it
manipulation.
not used under, I mean,
This is a
categorized under
separate
collection?
this is a separate interface only, which is not part of the collection interface. Here the way we store the data is different.
Okay. Okay, got it.
So you saw in the previous picture, right? It was not part of that collection framework.
Hmm.
If it is a part of the collection framework, it would have been there only.
So util.collections will not have this.
No.
Okay. Hmm.
So
Okay.
now we will read about this map interface and we'll see like what are the implementation classes, how HashMap works, how linked HashMap worked, what is the use case of tree map in detail.
Hmm. Hmm. Oh.
So I was telling about HashMap. So HashMap is again a data structure in Java which implements map interface,
Mm-hmm.
and the way we store the data in the HashMap is that has to be in the key and value pairs.
Okay. Hmm.
And HashMap has a unique key and only one value for each key.
Hmm. Hmm.
So till now, whatever we have read in the collection, we were directly adding value to the data structure or collection framework.
Hmm. Hmm.
But here the way we store the value is different. Here we store value in a key and value pair. So there are two part. One is the key, one is the value.
Hmm. Okay.
And it uses hash table as a underlining data structure. So internally it uses hash table for storing a data, and
Okay.
we can do it here like insertion of the data or deletion of the data on a constant time, like it is very fast.
Hmm. Hmm.
Like time complexity is the good here in case you have requirement of inserting a data or deleting a data, because if you know the key you can directly delete the data and you can directly retrieve the data, so you don't
Oh.
have to iterate the data to go and get the value.
Hmm.
So you can do in constant time like order of 1.
Oh. Okay. Okay.
So that is the use case of the hash map. So
Instant time performance.
performance is better here.
Okay.
So we'll go and we'll see, like I'll just create a hash map. So I told you, right, it has two value.
Hmm.
So you have to tell that key and value, type of the key and value.
Okay.
So I have told that my key, so first is the key and second is the value.
Okay.
So I'm telling that my key also has to be string or my value has to be also
A
string.
string.
So we have this in earlier we were saying add is the method to add the data, right? So in case of map we have put method which add the
Okay.
data into map.
Okay.
So let's say I want to add people's name, let's say Somnath,
Hmm.
and which city he belongs to. So I'll add it, let's say Bangalore.
Hmm.
Bangalore.
Hmm.
Let's say I will add it more data to this. I'll just add Rahul
Hmm.
is from Kolkata.
Hmm.
So one more. I'll add Ritesh
Hmm.
is from Ranchi. So this is how we add the data to the map, which is in the format of key and value.
Hmm.
And if you print this map,
Hmm.
it will print data in the key value format. So here you see it is printing Rahul from Kolkata, Ritesh from Ranchi, Somnath from Bangalore.
Okay. Okay.
So whenever we have a requirement of key and value kind of it, we will go for HashMap.
Hmm. Hmm.
And here you can get the data, like as I said, right, if you know the key you can get the data in one go. So for getting the data we have a get method, and
Get an key.
get which will take the key. So here key, let's say key is Somnath.
Hmm.
So when we get this it will return you the value Bangalore.
Ah. Okay.
So here you see it is returning the value Bangalore. So to get the value you have to read the data with the help of a key.
Got it. Got it.
So you can it can do in order of one. So you see it is not going and checking in whole map. It will
Directly it
directly
goes
go
and
to
picks
the
up.
map, and it will see that whether this key is present here or not. If it is there, it will return you to the it will return you the data.
Hmm. No iteration is there.
No. So one of the very very important questions of the interview point of view ki how HashMap internally work.
Huh, huh.
So that is very very important. It will be definitely asked